Good morning to all. Today I am talking about introduction to linear programming. The linear programming is allocation of limited resources among competing activities in the best possible way. The basic terms of LPP are decision variables, objective function, constraints, and non-nativity restrictions. The basic definitions are a set of x1, x2, etc., xn which satisfy all the constraints is called the solutions. Set of x1, x2, x3, etc., xn, which satisfy all the constraints and also the non-nativity restrictions, is called the feasible solution. If there are n variables and m constraints, that is n is greater than m, the solution obtained by making n minus m variables to 0 and solving for the remaining m variables. The n minus m variables with 0 value are non-basic, remaining m variables are basic variables, and solve this procedure is called the basic solution. A basic solution which also satisfies the non-nativity restriction. Among all the basic feasible solution that optimize the objective function. Matrix form of LPP. Normally, the data is given to the equation form. To convert the equation form, into the matrix form. The given question is maximize or minimize of z is equal to cx subject to the constraints ax is less than or equal to b or greater than or equal to b or equal to b, where c equal to c1, c2, etc. cn and x equal to x1, x2, etc. xn, and x be the given coefficient of the variables, so x1, x11, x12, x13, etc., x1n. Similarly, x21, 22, 23, etc., x2n, and also xnn. The basic assumptions of LPP is linearity, additivity, divisibility, certainty, and non-nativity. LP formulation. The formulation of LPP, on the simple examples, a company produces two items A and B. One machine and one worker are required to produce each item. Item A requires 2 machine hours and 2 man hours. Item B requires 3 machine hours and 1 man hour in a day. 12 machine hours and 8 man hours are available. Profit on A is rupees 4 per unit and B is rupees 5 per unit. And the question is how many units of A and B should be produced each day to make maximum profit. The formation is maximum of Z equal to 4x1 and plus 5x2. You have to assume the A be x and B as y. So 4x plus 5y maximum Z equal to, and you have to assume A by x and B by y, and therefore the item A requires 2 machine hours and 2 man hours. So 2x plus 2y is equal to 12 and 3x plus y equal to 8. And x1, x comma y is greater than or equal to 0 is a non-nativity. These are the formation of LPP. It's another one problem. The general form of LPP is maximize or minimize of Z equal to Cx, that is C1x1 plus C2x2, etc. Cn subject to the constraints A11x1 plus A12x2, etc. is A1n xn is less than or equal to B1. Similarly, the next row A21x1 plus A22x2, etc. A2n xn less than or equal to B2, etc. and AM1. And all the x1, x2, etc. xn is positive. It's a canonical form of LPP. It is a standard form. The general form is also a standard form of LPP. The conversion of maximize to minimize and minimize to maximize. In a simple way, multiply throughout by minus sign, you change the minimize to maximize or maximize to minimize. If maximize z equal to, for example, maximize z equal to 3x minus 5y plus 2z becomes minimize z equal to minus 3x plus 5y minus 2z. And also, suppose minimize value is given z equal to 2x plus y minus z becomes maximize z equal to minus 2x minus y plus z. Thank you.